All right, welcome back to Genius. So in this section, let's talk about comparison operators. We have a lot of comparison operators. So we'll just be looking at, in this section, we'll be looking at the first two. Okay, so comparison operators, we use them to compare values. All right, we use them to compare, is this value equal to this value? Is this value not equal to this value? Is this value greater than this value? You understand? So we use to compare. Okay, we use to compare two values, and when we do that comparison, the result of that comparison is always a Boolean. The result is always a Boolean. It's either true or false. Okay, so and remember, it is an expression. Remember, almost everything we do here is an expression. So when we are comparing two values, it's actually an expression. And remember that expressions will always be evaluated. So when Python interpreter evaluates that expression, it will give us a value. Every evaluation of an expression returns a value. Okay, so let's see what we have here. Comparison operators in Python are used to compare two values. All right, you use it to compare two values. All right, they always return a Boolean result. Okay, the evaluation of a comparison expression would always return true or false. Then this value, you can either store them in a variable or you can use them right away in an expression too. So these operators are commonly used in conditional statements and loops. In the next chapter, after we finish this operators chapter, the next thing we'll be talking about is the control flow. All right, we'll be talking about if the conditional statements, and also we'll be talking about the loops. Okay, so these are where we use these comparison operators very well. Okay, so when we compare, we'll compare something, and we would want to do something based on the result of that comparison. All right, so the first comparison operator we look at is the equal to operator. The equal to operator. Now, the equal to operator is a comparison operator that checks if two values are equal. Is A equal to B? Is 10 equal to 8? Is 10 equal to 10? Is 5 equal to 15? Do you understand? So we are comparing two values. It returns true if both values are equal, and false if they are not equal. So is 10 equals to 20? Of course. 10 is not equal to 20, so it will return false. Is 10 equals to 10? Yes, it is equal to 10. All right, so that is true. Okay, so that's how it goes. So look at the syntax. Why? Now we use this double in mathematics. The equal to sign is what we call the assignment operator. In programming, all right, a single equal to sign, that one we know as equal to sign in mathematics. That is what we use as assignment operator. So double or fade is what we use, what we call equal to operator. So we have a value in S, we have a value in Y. So we are comparing, is X equal to Y? So if X and Y have the same value, it returns true. If X and Y have the same value, it will return true. Otherwise, it will return false. Okay, so this is an example. Now, let me take you to the website, and let's write some code. All right. So I have X equal to 7. I have Y equal to 9. All right. So I will put the results of this expression. I will say X is X equal to Y. Do you understand? So if I print the result here, all right, I'm going to get either true or false. So you can see this equal to, now don't be confused. I want to explain this thing very well. In mathematics, all right, this is the equal to sign, right? This is the equal to operator in mathematics. When you say 5 is, when you say 5, X is equal to 5, that is equal to. But in programming, in computer programming, in Python, this particular sign, all right, this particular sign is called the assignment operator. We'll talk about it later on in this chapter, in this own session. Okay, double of it is the equal to. So this equal to, we use it to, this here we are using it to compare. This is the comparison operator, the double equal to. In mathematics, we use it to assign. Okay, so but here, this is called assignment operator. All right, this one is the assignment operator. Why the double of it is the comparison operator, the equal to operator. So we are asking, is X and Y equal? All right, so let's see what the result is. But already 7 and X is 7, Y is 9. So they are not equal. So the result would be false. The result will be false. You understand? So the result is false. The thing is this. You can actually, remember, this is an expression. All right? This whole thing, all of them is an expression. And we have the first expression, which will be evaluated first. This one will be evaluated. Then whatever we get here will now be assigned to this variable. So we can also, if we want to use it right away, we can just say X equal to Y. So we are printing this will be evaluated. S equal to Y will be evaluated, and the value will be given to this print function, and the print function will print it, and we're still going to get false. Okay, so this is what we are doing here. We can also say, we can do this on literal values too. We can say, is 7 equal to 9, or is 7 equal to 8? Right? We can do that with literal values. We don't even need to put it in a variable, but most times we actually store values in variables, and then we compare the values of those variables. So we are using integer literals. We are saying, is 7 equal to 8? If you do that, of course, it is false. But if I say, is 7 equal to 7? Yes, 7 is equal to 7, so it will give us true. Okay, I hope you understand this. So we can compare integers and floats. We can say, is 10 equal to 10? Of course, it's true. 10 is equal to 10. Is 10 equal to 5? No, 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 no. 10 is not equal to 5. All right? Now, you can also check, is 10 equal to 10.0? The thing is this is going to be true. Why? I have mentioned this thing before. Whenever there is an integer and a float expression, Python will convert this integer 10 to the float 10, and then compare the two. So it is true because Python considers int and float with the same value as equal. So Python would, behind the scene, convert this integer to 10.0, then compare the two. So they are the same. So if we go on and print and go to and say, is 7.2 equal to 7? Okay, no, it will not be equal, because 7.7, this will be converted to 7.0. So they are not going to be equal. This integer 7 will be converted to 7.0, so it will not be equal. All right, it will be false. So, but if I say 7.0, all right, this integer 7 will be converted to 7.0. So 7.0 equal to 7.0 will be true. Okay, it is true. All right. So you can also compare strings. All right, you can also compare strings. We are saying hello equal to hello. All right, where you use this this string comparison, you use it mostly when you're working with when in your web application or in your mobile application, a user gives you their username, their password, or their email address. They want to log in. So you will take that thing they give you as their username or their email address. Just like that, if you want to log into this application, this is our website now, this platform. All right, you give us your email address, you give us your password. So we are going to take that email address and the password. We are going to check it with the one we stored in our database. We are going to check, are they equal? So if they are equal, then we allow you, we allow you to log in. But if they're not equal, we'll tell you that no, you have your login credentials are not correct. Okay. So, but look at this one. This is lowercase h, and this is uppercase h. We are saying, are they equal? No, they are not equal. Remember that Python is case sensitive. They are two different things. Lowercase h is different from uppercase h. So let's go and write some string comparison. So I could say, um, hello, is it equal to hello? All right, you can see both of them have the same case. All right, both of them have the same case. All of them have the same case. So if I run this, it's going to be true. But if I try to change any of the case here, if I try to change any of the case here, we have all of them lowercase. Here we're having inside here, we are having one of them to be uppercase. So they are not going to be the same again because Python is case sensitive. If I run this, it will give us false because they are not the same anymore. So make sure that you're always aware of this case sensitivity. Okay, so they are not the same. As long as any of their cases, all right, never match, they will not be the same. Okay, so that is string comparison. So if you compare apple is equal to banana, of course, they are not the same. Apple and banana are not the same. They are not the same at all. So it will give us false. So they are not equal. Apple, banana, no, they are not equal. Hello, hello, yes, they are equal. All right, but this hello and this other hello are not equal because one of the characters in this other hello is an uppercase character. So Python is case sensitive, so it's not going to be the same thing. That is why most times when you're logging into the application and your email address, you did not, the first letter, when you signed up, the first letter was small letter E. All right. The first letter was lowercase, and you want to now sign in, you're not using uppercase. All right. It would not work because it is case sensitive. Okay. So that is it. So you can also compare strings. You compare strings and it will either give you true or it will either give you false. So we can also compare lists, tuples, and sets. In as much as we have not talked about lists or tuples yet, okay, but we are still going to talk about them and explain them. But already we have been doing some examples on it. So that is why we also have to bring this thing up. So when you have two lists, okay, this first list has 1, 2, 3. The second one has 1, 2, 3. Are they equal? Yes, they are equal because number one, they have the same elements in the same order. This one has 1 in the first position. This one has 1 in the first position. This one has 2 in the second position. This one has 2 in the second position. This one has 3 in the third position. This one has 3 in the third position. So they are equal. But look at this one. 1, 2, 3, 2, 2, 1, 3, 2, 1. It seems like they have the same elements, but the thing is that they are not in the same order, so they are not equal. So when you're comparing lists like this, they have to be the same elements in the same order. All right? If they are not the same elements, it is false. Even if they are the same elements, but they are not in the same order, it is also false. So be careful. All right? So let's go and do some coding here. All right? I have S to be 1, 2, 3. I have Y, okay, to be 1, 2, 3. You can see that both Y and S, all right, they have the same elements, and these their elements occur in the same order. So are they equal? Yes, they are equal. All right, look at them, they are in the same order, so they are equal. This is how Python does it. They are equal. But if I mistakenly, look at it, if I mistakenly take 3 here and say 2, they are no longer in the same order. They have the same elements, but they are no longer in the same order. So if I run this thing, it's going to be false. Do you understand? Now, even though if they are in the same order, okay, and then I now add 4 here, they are no longer the same because the first one has just 3 elements and the second one has 4 elements. And they don't have, this S does not have 4 in its own list. So it will also be false. They are not equal. Look at it now. They are not equal. Whether the same elements or even in the same order, they are never equal. So they will also, they still give us false. Okay. So this is for list. You can also, the same thing applies to tuples. They have to be the same elements and they have to be in the same order. All right, they have to be in the same element, they have to be in the same order. Let's take a look at tuples here. So instead of this bracket, square bracket, oops. Instead of this square bracket, I'm going to change it to parentheses. So this is, we are changing this thing now to tuple. All right, don't worry, we'll talk about that later. So they are in the same order, the same elements, it will give us true. All right, but if we try to change the order, it will give us false because they are not in the same order. All right, so this is for tuple. Now for sets, okay, look at what set says. It says the order doesn't matter. When it comes to set, when you're working with sets, all right, they just have to have the same elements, but the order doesn't matter. So this is basically the opposite of what the list and the tuple is doing. So to convert this thing to set, I will use the curly brace. Okay. And if you look here, they are not in the same order. They have the same elements, but they are not in the same order. All right, they are not in the same order. If it was list and tuple, they would do what? They will not return true. They will not be equal. But here, the order doesn't matter because set are not, they are not ordered element data structure. So for set, it would return true because the order doesn't matter. What matters is the number of the elements. So if I try to add another element here, 4, it's no longer going to be equal because, of course, they don't have the same elements. So if I run it now, we are going to get false. Why? Because they don't have the same elements. So if they have the same elements and maybe they are not in the same order, those elements are not in the same order, it will still give us true. It will give us true, okay? So we can also compare dictionaries, okay? We can also compare dictionaries, okay? When you're comparing dictionaries is always going to compare the keys, all right? Look at it, dictionary 1 is equal to dictionary 2. Yes, they are equal because look at dictionary 1, A1, B2. They are equal. The keys and values are the same. But if you try to say any of this equal to dictionary 3, it's not going to be the same thing because first of all, they are not in the same order. And secondly, okay, all right, so the order doesn't also matter. In dictionary, the order doesn't matter. The only thing that matters is the keys and their values. You might not understand dictionaries now, but try to grab anything I'm saying here because we haven't talked about dictionary. So the thing is this. Let's go back to code. All right, let's take a look at dictionary. So dictionary, I have dictionary S is, so I'll have A, the value is 2. And I have B, and the value is 3. So this is a dictionary now. I have the next dictionary, A. I'll just have to copy this one. Okay, I'll just have to copy this one. And again, I will copy this whole one and make another one for Z. But let me use A. So now here, I'm just going to rearrange the A. I'm just going to rearrange the elements. So remember, the order doesn't matter. All right, when it comes to set and dictionary, the order doesn't matter. But now so if I say is S equal to Y, dictionary S has key A and the value is 2, and dictionary has key B and the value is 3. Y also has key A and the value is 2, and B has also has B key and the value is 3. So they are equal. Both the keys have the same, they have the same keys and they have the same values. So they are going to be equal. They are going to be equal. But if I try to say X is equal to A, remember the order X and A, their orders, the keys are the same. The values of these keys are the same, but their orders, the order in which they appear are not the same. So, but in dictionary, the order doesn't matter. So it will give us true. Okay. But if I try to change the value, if I try to change the value of A here, you see now, their values, they have the same keys, but they don't have the same, their values now differ. So when you run this, it's going to give us false. They are not the same anymore because, yes, they still have the same values, but they have the same keys, but their values have changed. So for X, A has value of 2, but in A, the A value there is 3. So they are not the same. Okay. So if you also change, instead of A, you say Y. So now they no longer have the same keys. All right. So it would also give us false. So for dictionaries, okay, dictionary is only going to compare the keys and their values. As long as the keys and their values are the same, all right, it will be true. They are equal. The order doesn't matter. In any order they come in, it doesn't matter. But as long as the keys differ or the values of the keys differ, it will be false. Okay, so what is the difference between equal to operator and the is operator? We'll still talk about the is operator later on. So when you say is X equal to Y, the equal to operator is only checking for their values, nothing more. But the is operator is only checking for their object in memory. So let me go and explain better here. So let me just do something very simple. X is equal to 8, Y is equal to 10. Okay, let me still use 8. If I say is X equal to Y, right? Here we are actually comparing their value. Yes, they are equal. Their value, they are equal, so to give us true. But if you say is S is Y, okay? This is operator is comparing their memory location. Remember, I told you that whenever you create a variable, all right, this variable is the address of the memory location where this 8 is being stored. Remember in the previous class. All right, what we are doing here is that we are storing 8 in the memory location because the memory is where we store our data. So we want to store 8 in memory, and as soon as the computer stores the 8 for us, it will give us the address of that memory location, and that address will be stored in S. So whenever you now want to make use of this S, the Python interpreter will go to that memory location and fetch the value. So here, with the equal to operator, we're only comparing the value, nothing more. But if you're not saying is S is Y, when you're using this is operator, you're comparing their memory locations. And you already know that they have 2 different memory locations. All right? X is in a separate location, Y is in a separate location, but they are not the same, so it will give us false. Okay, yeah. It's giving us true. Yes, look at it. Yes. I didn't mention this thing. There's something they call, I've forgotten this thing. Something of pool. Now, the thing is this. Look at what most programming languages do. I know of this thing in JavaScript, okay? When you have the same value, look at it. When you have the same value, you are assigning, you created a value, you are storing 8 in a memory location, and you assign it to X. If you try to assign another variable 8, Python would go and, instead of creating another memory location, all right, it will point Y to the other memory location. And that is why X and Y are pointing in the same location. But if I try to say 82, all right, Python will create a new memory location for this 82. Because, look at it, Python will take, when you say X equal to 8, Python will take 8 and store it in a memory location. And that memory location, the address, it will store it in X. When you now say Y equal to 8, Python will go and check, do I have this 8 value? Do I have a value? Do I have any memory location where I stored 8? if I have something like that, there's no need for me to create, this is for optimization. There's no need for me to create another 8 value because it's going to be redundant. I will take that 8 value, that same memory location, I will not give it to Y. So that is why when we when we were checking about the location, it gave us the same thing. But right now, we are not saying Y is equal to 82. So Python will go and check in its pool. I've forgotten what they call that pool, the name of that pool. Okay, Python will say, do I have 82 in the pool? No, I don't have 82. I only have 8. But this user is not requesting for 8. So I have to create a new memory location for 82. Now, Y and S are no longer pointing to the same memory location. So this will not give us false. Or do you understand it? So, but if I try to say Y is equal to 8, Python will go and check, do I have 8 in my pool? Yes, I have 8 in my pool because I have already created the first one. So I will now have to point this, instead of creating the new memory location, I don't have to waste my memory. I will just point the memory address of the first 8 that I have and give it to Y. So S and Y will be pointing to the same location. Don't worry, as we get more advanced, you get to understand this thing better, okay? So this is the difference, all right? So 1, 2, 3, all right? We are not saying C is equal to A, okay? So we are saying C is equal to A. So we are pointing the memory location of A to C. So C and A are not pointing to the same memory location. And if we run, they are, A and B are actually, they are equal because of their values. But if you say A is B, now, I have to also explain this. There's something we call primitive and reference objects. I don't think I have mentioned it before, but it is something we will have to talk about. Now, the reason why when I was doing X equal to 8 and B and Y is equal to 8, and when they point to the same, they were pointing to the same location because they are primitive values. Now, the reason why A 1, 2, 3, B 1, 2, 3, they are supposed to be pointing to the same location because X equals to 8, Y equals to 8 they were pointing to the same location. But this time around, okay, these are reference objects. So I wouldn't want to go too much into details here. We will have to explain primitive and reference data types so that for you to understand this. So we'll find a way to explain it in one of the sessions, okay? So A and B is not pointing to the same memory location. But A and C are pointing to the same memory location because when you say C is equal to A, you're saying, okay, Python, take the memory location of A and assign it to C. So now they are pointing, A and C are pointing in the same memory location, all right? But A and B, because they are two different objects, okay, lists are reference objects. So because they are pointing to they are pointing different objects, they are not equal. So just be careful when you're actually comparing. When you're comparing primitive values, primitive data types, all right? When they are those primitive data types, when the variables their values are the same, they will point to the same memory location. But when they are not primitive value data types, when they are something like list, tuple, dictionary, something like that, maybe classes, okay, they will not be pointing to the same memory location. All right, don't worry, we'll have a separate section and I will take time to explain these things, okay? We also have the not equal to operator. The not equal to operator is a comparison operator used to check if two values are not equal. The equal to operator checks if two values are equal. But the not equal to operator is checking if two values are not equal. So basically they are the same, they work in the same way. So it will return true if the values are not equal, if the values are different, but it will return false if they are equal. So when I say A not equal to B, if A is 8 and B is 5, they are not equal, so it will return true. But if A is 5 and B is 5, they are equal, so this not equal to return false. So it will return true if A and B are not equal. So we are just trying to check, are they not equal? That's what we are concerned about. So if they are not equal, it will return true. But if they are equal, it will return false. So that's just the whole thing. Almost the same thing with the equal to. But the thing is that here we are checking, are they not equal? Okay. So basically the same thing. 10 not equal to 5. Yes, 10 is not equal to 5, so it will return true. 10 not equal to 10. Of course, 10 is equal to 10, so it will return false. So I don't need to explain too much here. All right. I don't need to explain too much here. Hello not equal to hello. Remember, the H here is uppercase, so it is not equal, so it will return true. Apple not equal to apple. Apple is equal to apple, so it will return false. All right. So the same thing both for tuples, both for sets, both for dictionaries. All right. As long as they are not equal, it will return true. If they are equal, it will return false. So there are scenarios where we actually use this. There are scenarios where we actually use this not equal to operator. Okay. So in a conditional statement like this, we have the password, we have the user input. They are not equal. Admin 123 is not equal to admin 321. So when we say is user input, if user input not equal to password, yes, they are not equal, so it will be true. So we are going to tell the user access denied. Don't worry, we'll be using this thing very well when we talk about when we start talking about the if statements. Okay. So basically, the not equal to is checking is the two values not equal. If they are not equal, it will return true. But if the two values are equal, it will return false. Okay. What is the difference between not equal to and is not? Basically, not equal would check their values, will compare values, but it's not will compare their objects in memory. Just almost the same thing with equal to and is operator. Okay. So I'm not going to explain too much here. All right. If you understand what I explained in the equal to and the is operator, you just have everything here. Okay. So now, this is where we end the session. If you get confused, please reach out to me, reach out to us, chat us on WhatsApp, and we'll explain more and better to you. Okay, thank you very much, and I'll see you in the next session.